So hi again, Jeff and Doug back. We're at AMD now, and where Margaret Lewis is going to tell us about what's new and wonderful at AMD and give us a little bit of clue about why this car is spinning around behind us on the screen. So Margaret, go ahead.
Well, before we talk about the car, I want to make note that AMD and Cray made the top of the 500 list with a Cray system called Jaguar with our 6-core AMD Opteron processor. So that's caused a lot of excitement for us at the show. And not only were we on the number 1, but we were in top 5 systems of the top 10. Now, if we look over here at this car spinning around, you can say, what's so interesting about this? This particular demo is being driven by our next generation processors, our Mani-Core processors. There's a cluster over in the Mellanox booth, and there's 25 booths throughout the show floor that are running the same demo based on that cluster. And if you go over to the Mellanox booth, which I think you guys will do, you can see the 3D immersive version where you can actually walk into the car with your 3D goggles and kind of really get a feel for what that new design is. The other thing we're doing at this show is doing a lot on our stream technology, really using CPU, GPU together to provide that extra kick of computational power. And in fact, the number 5 computer on the top 500 list is a supercomputer that is using our ATI GPU technology. Our Mani-Core's design is a CPU that has either 8 or 12 cores per processor. It has 4 memory channels, so we've doubled our memory bandwidth, and it's going to be delivered in our same power-efficient envelope. So we always are going for a balance of price, performance, and power. And when you start with Mani-Cores, you get a system that is upgradable. So you'll start with Mani-Cores, but you'll be able to upgrade to our next generation of processors. And it's that upgradability that you see in systems like Jaguar. And they started out as a quad-core AMD Opteron processor system and upgraded to the 6-core to make that top 500 listing. System number 1 and 3 on that list are both upgrades from quad-core to 6-core. And in fact, we have a video showing researchers at the University of Tennessee upgrading it, and I think it was 5 minutes per server to do the upgrade, which is kind of a phenomenal idea for the increase of computational power that you got.
What'd they do with the older chips? Can I get some of those, maybe?
I think we're putting those in earrings and
I don't look good in earrings. So.
Yeah. Don't know. That's a good question. You could take those old chips and put them in another board, huh?
Yeah, well, that's the nice thing about it. But of course, once you get them, then you're going to want to upgrade them at some point.
Then
so
you pass them down to your children.
Right. So my daughter's 52P cluster is getting a little slow. I think I'll upgrade it. It's only dual cores, so we'll upgrade her. I think to quads next year.
Yeah,
you know,
she's going to college. She needs a little more horsepower.
That's right. That's right. So that's a lot of great things going on at AMD, and we'll find somebody to talk about the GPU.
Right.
And because
Go around to the other side.
that's always exciting. So thank you very much.
Thank you.
So we ventured to the other side of AMD, so to speak, the AMD booth, and we're going to learn about what's new with the coprocessor GPU technology here at AMD. So I'm with Mike Houston, and he's going to tell us all about it.
So we're showing a couple of things here. And so let me start with the screen up here first. And so there's actually a couple of things happening all at once here. So this is actually running our iFinity setup. So that's the first thing. So off of one graphics board, we're actually driving 6 displays simultaneously. And so this is a board that will ship shortly. It has 6 mini DisplayPort outputs. And so one board driving 6 displays. So you can do it under both Windows, Linux, and soon on Apple as well. The demo itself is actually computing a high-res FFT in real time. It's a 2K by 2K FFT that underlines this wave simulation, right? So you can change wind patterns and everything else. So besides doing the simulation at high fidelity, we're also rendering at high fidelity in real time. Okay. So if we move this way a little bit, so that was running on Windows, just so people know. This one's running on Linux, so perhaps the Linux IOs will be more interested in this. So this is an interesting demo. This was actually put together by Los Alamos National Labs. It's a gas dynamics simulation. This is a real production code that's been ported to OpenCL. And what we're showing it running on is our latest generation hardware. So this is running on the 5870 hardware, what we internally call the Cypress board. So this is an OpenCL demo. And what you're seeing here is a speed up of 20x over a single core Nehalem running this application on the GPU. So this is production code. It was a fast port by Los Alamos guys. The interesting thing to note is it's not just AMD running this. If you actually go to the Los Alamos booth, you'll see the same demo running on AMD, Intel, NVIDIA, IBM Power, IBM Cell, all simultaneously. Single code base. So that's the power of OpenCL. So it's restarting, it didn't crash. Don't worry. And so this is another really interesting one. So what's happening here is this is a really high-res data shot, right? These are the files from the Hubble telescope. We're in the Orion Nebula here. What it's doing is calculating real-time histograms. So this is a massive image set. We're navigating through it in real time, calculating histograms, and doing tone mapping. So you'll see we're adjusting the exposure dynamically. And it's this massive surface running on a single board. Also all being done in OpenCL and all in our latest hardware. So that's kind of a quick overview, at least the demos that we're showing, and sort of what you can do with OpenCL and where we are with OpenCL right now.
So you've got some new GPU technology chips released today. Is that this week?
So on the GPU side, we've actually been shipping this board now for a while. We've been shipping it since September. We have fancier CPUs in the booth that you can see that are not released yet. That you can see demos on. But you can actually buy this board now. So we've been shipping this board for a while. It does DX11. It's fully OpenCL compliant. We have full IEEE double precision, the whole kit and caboodle on this hardware. And those features are slowly coming online in our CL implementation.
Oh, okay. And is it OpenCL that's up and running? You can.
Yep. So you can download it now. It's public. We're still in beta, but we support Windows, Linux, and although we're showing the GPU here, we also support x86 in general, and we don't core lock. So our stuff will run just great on Intel boards. I mean, obviously, please use an AMD processor, but it'll run just fine on Intel.
Okay. Jeff, any...
Yeah, tell me more about the GPU. I've been hearing some stuff on the web that it's unbelievably fast. Do you have any more details?
Yeah, so I can give you some idea of sort of what we're talking about. So I'll give you the peak numbers. So single precision, 2.72 teraflops. Double precision, 544 gigaflops. That's full IEEE, including an FMA. So that's IEEE 754 2008. In terms of memory bandwidth, it's 153 gigabytes per second is the external memory bandwidth. This chip also has scratch pads on it, so high-speed local memories. The aggregate of those local memories is 2 terabytes per second.
Wow.
So right now, this is the most advanced chip that you can get in terms of double precision throughput and its capabilities. And as I said, shipping now, you can go to your local supplier and buy the consumer edition of this board right now.
So I can go to Walmart and run something that's 3 times faster than 15 years ago.
Yep. Well, probably more than 3 times faster. I mean, so the funny thing is so, you know, I've done supercomputing stuff for a long time. And back when I was in college, the first machine that I had access to that was a big machine was Blue Horizon at SDSC, right? So that was a 1 teraflop supercomputer. This is a 2.72 teraflop board.
About that big versus a room.
Yeah, well, the chip is that big. It's about the size of a penny, right? And it's on a board. It's something you can buy as a consumer, and it's less than $400 for the consumer board. You can get this now, and you can do things that, I mean, really used to only be achievable on large machines, and you can do this in workstations now. And more importantly, you can put multiple of these things in one box. Right? You can put 4 or 8 of these things in one box and get just incredible horsepower.
So maybe we don't need to upgrade your daughter to the 6-core. Maybe we just get her GPU.
No. You get her the 6-core. You get her a dual socket. So 6 cores, 12 cores total, and a couple of these, and she's off and running. Right? She really needs that for Facebook, I'm telling you.
Well, it
The way my wife does it definitely helps.
I think it will make the internet faster. That's what they tell me.
Yep.
So thank you, and more great stuff from AMD.
Thanks, guys.
Thanks.
So I just wanted to also mention that Windows needs 6 monitors. Linux only needs 1. Where we got that. I just want to be clear about that. Okay. Thanks a lot.